So I appreciate you coming, and again, I apologize, I'm gonna slide up so you can actually get going, but I'll be out, so there's don't feel that I gotta get kicked out of here.
That was actually a good segue, because, so, to give a quick understanding what an ontology is, it's a data modeling structure. If you're familiar with anything that says AI comes from an ontological model. It's the interrelation. How do things relate? To go to the problem that we're talking about in the Army. So my background is, I started out Signal but never worked Signal, went to PSYOPs, went to Special Forces, ended up going down.
Oh, no,
like
if you'd have said you were PSYOP before you came in, we might have had a different discussion.
So PSYOPs as a lieutenant, then went to third group, and then career took me down to the black side of the world. But so I have an understanding of operational focus. I understand how things come together. I understand networks. I have a computer science background. I've been doing the data science on the ontological model for about a decade now. Kind of taught myself, then did a couple of courses from Stanford and MIT to really hone it. If you were to look at how ontological models are used in industry, I tweak them because the Army knows more than what an industry knows based on just looking at relationships. We get down to the nitty gritty. Let me get into the brief to show you some. I'll pull up the actual models so you guys can see the flavor of it and see the value of it, but it's really the interrelationship of things. So as the Colonel was talking about, if you want to know how EW, cyber, and everything relates based on tasks, systems, people, functions, capabilities, data exchanges, information exchanges, all that's contained within the model. We can easily ask questions to it to see how do we actually look based on the model relationships. So I kind of coined this phrase based out of something the Navy's doing, and I know that's a bad term here, but mission engineering. So you've heard the term model-based system engineering. Everybody says they do it, but they use a concept called SysML or UML, which are different modeling capabilities that are very rigid, very structured. We change this to mission engineering because everything starts with doctrine. Everything starts with operational processes. In our models, you'll be able to read the text to actually see MDMP and how that actually works, the 7 steps, D3A, IPP, targeting. So again, like I said, I take the standard definition, which is the interrelationship of things, and changed it based on how we actually do things in the Army. So the bottom left is an actual Visio-esque type way to build an ontological model. You can see all my models structure with organizations, processes, functions, tasks, and then an acronym we came up called DICUI. Data, information, knowledge, understanding, and intelligence. That's really what we care about, of what's being exchanged. On the left we have systems, on the right we have people. Very easily read structure. This modeling language is not a structured language, it's in common English. So whatever nouns, verbs, pairing I use is what's reflected in the model. So it's something that an operator, Keith and I did this for SEAM optimization, and we had more interaction from green suiters, master sergeants, warrant officers, captains that would actually go to the board and actually help us manipulate the model because they could read it for the first time. Most modeling languages, if you're not a computer scientist, you can't do anything with. You just have to trust what's coming out of it. What we show here on the left is what we create. What shows on the right is what the system creates. All the true interdependencies of those organizations, processes, functions, and so forth. So you can see that on the left, it looks like a very linear, very structured, sequential model. What we see on the right is really what's happening is a chaos. It's everything relates to everything else, but we define how does that happen. And then the key to this is the semantics. Semantics is just a fancy word for describing something. In a machine language. We describe this so it's both machine readable and person readable. So again, the model-based engineering, the Colonel said it, it's a holistic look at everything. We don't limit ourselves by domain. We can start with a simple question, expand out, and come back in. Our models, I kind of coined the phrase and wrote a paper about process-driven ontologies. That's what's unique about us. Most ontologies don't look at a process, they don't want to be hierarchical. We do. We want to look at the process and how things relate to each other by better definitions as opposed to just empirical data. So how do we do that? We deep dive doctrine, we do the data mining, we extract pieces out of that. All along we're inputting that into the ontological model. We build up these process maps to show how we see things relate. We usually generate those, go back to the SMEs and validate those pieces with it. Once we get those validated, then the model comes out, or the details within the model, which is the centerpiece. I'm sorry, the centerpiece there. We then create more visualization capability to be able to show that really how things interrelate, and what you can do out of that is you can track requirements. If you're looking at material, what contracts those requirements are mapped to, what schedules of design, what are the system functions, APIs. We actually can relate to if there's cross PM, cross PEO needs here. We can show based on how this relates, who owns what portion of the requirement, what are they doing, how does it tie to their schedules, what contracts are doing it, so we can tell early on in the game if things aren't gonna line up correctly on how we actually produce something. As we get to this multi-domain capability, we're gonna have a lot bigger problem here because all the PMs are still focused on individual areas. The PEO C3T is the network side, the PEO IEWS guys are looking at EW spectrum. There's interrelationships between those two PEOs, but the PMs are not necessarily working at the same pace and same priorities. We can help to organize that based on how we write requirements. And please interrupt me at any time. What I plan to do is I'll jump to the models. If there's a time you have a specific question, it might be easier to look in the model on how we actually do this. So please feel free to interrupt. The next piece is that up here is kind of how we structured. I mentioned that ours is very hierarchical. We look at services, capabilities, functions, activities, tasks. Then we map that into, like I said, the organizations and lower. Everything starts with the operational process. We build the knowledge pieces in the model. Once we get to a fairly mature knowledge-based model, we kind of look at, all right, how do we access the data? What's the association of information? How do we share the knowledge? How do we apply the intelligence? You can actually query the model to generate unambiguous requirements. So here's one we took out is, as an EWO, I add jerful protection to emitters of interest on EWPMT in order to deconflict emitters. It's very hard to misinterpret that requirement. And if you do misinterpret it, all the data is contained what it actually means in the model. So if somebody says, well, what does it mean to jerful protection? We have the definition, we have the data structure of what a jerful contains. So if I'm building a system, I'll know what APIs, what information I need to pull in. I mentioned we have the systems and the people. So there's always a relationship to who's doing what task and what system. If there's not a system, then we'll put system X or the system that you're going to build if it's not an existing system. There is a little science to this, like the I-add piece or the shall statement portion of it. That's not contained in the model, but it's an easy way to put that in so you can extract it out. The green boxes, as we move across, what comes out of this is not only kind of your requirement and structure for how you build a system or how you look at doctrine, it's you get your semantic model. If you have an AI or machine learning requirement, there's different levels of what artificial intelligence machine learning can achieve. There's the concept of unsupervised learning, where essentially you just feed the machine a bunch of data, let it pick out the patterns. That's not going to work very well for the military. It's the old war game structure where if you send it a bunch of data to defeat your enemy and the objective is total, to win the war, the easiest path is going to be destroy everything. There's the other way of supervised learning, which is what the military is probably going to be pushing, is where you set your left and right limits and you're looking at what decisions, what is a pattern within the information flows to help me make my decision. What we provide is that base pattern structure, so the machine can then find other patterns that maybe we don't see based on how things are operating. But you set that core up, but you set that up based on how you start the early processes within the development of a capability. And like I said, so as this matures, you get to that level of where you need to build artificial intelligence, if not. But the key is from requirement development to system development to fielding and training, you're following basically the same model structures contained within that same model that everyone can extract the data out for how they need it. This next slide kind of shows you how operationally we can align the model to the structure. So you guys are all familiar with the brigade, battalion, company structures, operational, how things are aligned operationally. We start to look at, so the decision factors are 1 to N, based on how much data they have. If they have more data, they can make better decisions. Less data, they are going by their gut feel. We start to show that the model down below is equivalent to what we show at the brigade battalion. Brigade, you're going to have a staff doing a lot of tasks, a lot of functions, a lot of people coming together to achieve something. As you move further to the right on the model, it's hard to see on the screen, but these diamonds are the tasks that are actually assigned, the eight tasks that are assigned based on whatever function we're doing. On this model thread, we're delivering an EW effect at the very end. So we show that the task at the end is deliver an EW effect. This is everything that has to happen to the left of it for us to do that. There's multiple systems involved. There's targeting work groups, there's IPB work groups that are all involved. The SEMA work group are all involved in how do I actually get to that task down at the end. We show how all that interrelates and how the information flows back and forth. What we show on the right-hand side through these lines is although he only has one task, he has a lot more data coming into him at real time to say how, is a target still available? Did the target move? Is the signal of interest that we're looking for, is it still relevant? Is it still around? So although he has one task, he has a lot more variables coming in that can affect that task. What I'll show you in a second in the model, we deep dove the sensor process. How do sensors collect and what do they actually do, and how does it feed the tasks up the stream? We'll inject execute nav war, and I'll show you how the data changes in real time in the model to show that your relationships have now changed because you injected something new. Next slide, just there's multiple ways to look at this. So you can look at it a very workflow description type is the top portion. What leads to what? These are class relationships. So if we want to look at it from a very high level, we can say, all right, based on X number of systems, based on X number of people, based on X number of tasks, this is what manning should look like. Or based on X number of personnel, X number of tasks, X number of data exchanges, this is what the system should create. So we can look at it at a very high level to get that kind of organizational structure down. The bottom portion goes into much more detail of exactly what would that look like. So if you're a system developer and you want to know exactly what your API interface needs to support, within the model we contain what data is being generated, what format it's in, and who needs to consume it. The beauty of the model is you can look at it from any direction. It contains all this data, but if I'm a system guy, I don't really care necessarily maybe about the organization at that time. So all the relationships to the organization are still there, but I'm just going to look at it from a system perspective, and it'll tell me what's important to me. Are there any questions so far?
I got tons of questions, but I'll wait.
So let me jump into one of the models here, and then we can kind of use this as an interactive piece. I'll start with, so this again is kind of the structure. It's a little bit easier to see. So again, I built this. This is the tool set I use. Let me introduce you to that real quick. So this is a tool set called Protege. It's based out of Stanford University. I've used quite a few different tool sets, but this is by far the easiest one to use and easiest viewer. The Air Force AFRL has created their own unique OWL viewer. The Navy uses ontologies quite a bit, and I don't believe they have a unique. They use Protege and a couple other platforms to actually build the models. Protege is by far the easiest one to use that I've come across. And they continuously update this. I heard the Colonel mention ITN. So I was one of the original developers of the ITN ConOps. To go into a war story, Colonel Grabowski was with TICM TR at the time. He came up with this concept. It was JTRS at the time, and if you're familiar with that, they were building waveforms over here, radios over here, net managers over here, and the things were supposed to magically come together. That's when I started researching ontologies, because I was in the middle of that and realized none of this shit was going to work, so how do we actually get to the point? So that's when I went off and started researching this. Greg came up with this concept of ITN. He flew me out here to Gordon. We talked for a little bit. He had 2,000 plus requirements. I sat down, put his requirements, these are the actual requirements up there where you say CDP requirement, INMS 100. We sat down, I mapped his requirements, stayed up all night, mapped his requirements into my ontology. And the next day we spent, all right, what do these requirements actually map to? By the end of the week, we had those 2,000 requirements reduced to about 820, 850 ballpark. Because I was able to show where there's duplicative, where there was, you have a requirement out here that supports nothing. Why do we have it? Or in some of these cases, we show where the radio platform and the net manager own the same requirement. But someone has to do something first before they do it. The radio has to understand its structure before the net manager knows what to plan. But we were building all these in parallel. We were building the waveforms and the OEs in parallel. So there was more meetings where I said, hey, we're going to do API X. And the radio platform was like, no, we're doing API Y. And even though it's the same company, they weren't communicating. So we were able to show those interrelationships. Out of that, we were able to produce a ConOps, the ITN ConOps, within a matter of weeks. Though it took the longest was getting approval. We got approval from the start of the ITN ConOps to the end in less than a year, which is pretty Herculean effort here. We wrote the entire ConOps based on the ontology in about a matter of 2 to 3 weeks. General Gallagher at the CFT, I believe, has gotten his hands on that because I was sitting in a meeting and I heard him turn to one of his, I think it was Major Wong or someone else, and basically was like, this is one of the better documents I've seen come out of the cyber COE. It was written 6-7 years ago, but it was based on the entire ontology because it showed how everything related. There was no ambiguous way to look at how everything came together for ITN. Now they're doing the ITN, which is based on the premise of ITN. So again, you can capture requirements, show how all they relate. So here's one of the models we did for the SEMA side. So here we have the sensor collection ops. We show that you conduct sensing, then all these relationships, here are some of the tasks. So inside of sensing, we show that there's a process. There's data storage, data processing, data normalization, and data harmonization. Just fancy terms for saying how do we actually structure the data, how do we actually store it. What we're gonna do is we're gonna inject, so this sensor right now is not doing anything for NavWar. We're gonna inject the execute NavWar piece to it, which is this box that just came flying in. You saw the lines go up. So what it's telling the model is we just injected a new relationship. We have a new class, so we want to show what are the relationships now when we ask the sensor to do NavWar data. So you see the relationships that come back and forth, which is basically a command to say, hey, reconfigure to do NavWar, response back basically saying, all right, we got it, we're reconfigured to do NavWar. Now as we look through the sensor processing, what it's doing, what you'll see, what you want to look for here is there will be additional lines that grow out of this as we start to highlight these, because it's going to show that based on the NavWar, there's new interfaces that have come in, or new exchanges or interrelationships that have happened based on what its process is. So we have now new data that's actually being flown through the sensor piece within the model. Obviously this isn't real time with the sensor. It's just showing what's supposed to happen for that sensor now. So we can eventually get to the point to determine within the model what type of sensors they are and what their role is. So if I injected NavWar into this and that sensor did not have a NavWar capability, the model will tell me there's no change to the process or there's no relationship there, which means you're picking the wrong sensor to execute NavWar. So again, when you look at the doctrinal piece and the organization material, you can really align how all those come together. And as we start to go down this path upstairs, Jeff Gagnon, who understood the model, was like, Matt, I need to know if we put X, Y, Z equipment in there in the back of a striker and I have 4 seats, who do those 4 seats belong to? So the way we do that is we put the striker underneath the organization where it resides. We put a max value of 4, which means only 4 bodies. But then we put the functions and tasks that those systems that are mapped to that vehicle are supposed to do. Well, we also have the mapping between that system, that task, to the person. So what comes out of that query in the model is, well, you have 5 people that need to perform these 4 or 5 tasks, but you only have 4 seats, so what do? Do I take a piece of equipment out, add them to another vehicle, make him the driver, and now he has a dual function? But we can start to do that true analytics based on this model. Instead of doing these guesses of how many people need to be out there, we can pull quantitative data out of here, qualitative too, because there's mathematical algorithms that we can put into the model that tells you what right should look like based on weights and measures, how we add bias and variance to the model. We've touched on how we do the requirement piece. Obviously, as we develop these models, we did do, for SEMA optimization, we have all the EWIDL tasks for EW, spectrum management, cyber, both offensive, defensive, and SA. We have SIGINT, we have UMENT, we have a targeting process, which means we have a lot of the fire EWIDLs in there. What else do we do? Space ops, and PsyOps, and IO. We have those tasks in the model already to show how that relates. What we're going to start doing for Jeff now is adding the systems that he cares about. But again, we can start to track how all does that come together as we start to build these SEMA capabilities and integrate people across domains. What does that really look like, and how do we do that? Again, it's better analytics. All of us can go through and read thousands of pages of doctrine to try to pull out the right answer. All that's already contained in the model. Now we just need to ask the model what questions we get the analytics back. So now I'll take any questions you guys have and see if we can maybe, and if the question is something I can show you the model, I'll pull it up as in the model.
So who manages that environment?
The model structure itself. So I build these, but I've been able to train people. I have a partner of mine who has 0 operational background. He worked for CERTIC for a while, very technically savvy. Within a matter of 2 weeks, he was building his own models. This is not hard. Let me show you real quick this piece, and you can kind of get the understanding of why. Another war story. So the Boeing 737, when it was coming together, Boeing was trying to just determine how much weight the entire aircraft could contain. They were doing all their modeling in what's called SysML, which is a modeling language, system modeling language. They couldn't come up with the actual weight of the aircraft because each, the engine side did their model, the fuselage did their models, but they couldn't calculate the weights because they all did them differently. So they ended up having to shut down production, basically, send all their key engineers to a 6-month SysML and then it still took them 2 to 3 years to actually get it right. That's how complex that modeling language is. This one, it's all written in common language. I could teach you some of these icons, what they mean. I actually sent Keith a very good definition of what you actually manipulate within the model.
Well, if you can do it,
So Keith,
How true.
we're gonna be able to train so what I'm showing you here is essentially the extract of what I did. It basically just creates that sentence. You build what's called a triplet. A triplet is a class relationship to another class, a class relationship to an interval. A triplet means it's an object predicate, subject, object, predicate. So the subject is the noun. The predicate is the verb. And the object is what you're doing it for. So if you can write a structured sentence, you can build this model. So in some of ours, we have, for EW attack, we have, if the task is EW and it relates to something in the AGM or how you get into the targeting piece, you can say EW attack collects data from AGM or provides data to AGM. So operationally, you can easily put this down, and it's a way to put your knowledge into a model so everybody else sees what happens. We've all had the experience where if you read an FM, you think that's how it's done. Well, not really, because if I read an Intel FM, it doesn't tell me how the EWO participates in the IPB. It just says he's there. It doesn't tell me what he does. It just tells me he's there. You read the EWO one, it's all about what EWO does, and then it says participates in IPB. But you never get the connection of what is he doing for the IPB? What is he doing for targeting? We've actually been able to extract out of the targeting process for precision fires, if we want to do a non-kinetic versus kinetic, what data needs to be put into the HPTL, into the AGM, into the target requirement, the TAR, target, I forget the acronym. But we can show what non-kinetically or from cyber, from EW, from potentially space needs to be put into those doctrinal information to say, hey, we need a seat at the table for the EWO to be able to do this. Keith and I were having a conversation. If a signal pops up on the battlefield, you might have milliseconds to seconds to react. If we don't know what we're doing with that, and there's not a person on the planet that can process data that fast to be able to do that. But if we start to annotate what actually has to happen in the planning phase, have the data contained in the AGM or as we get to the actual targeting list, the specific data of how to attack that target and what the priorities are. Then we can build a system that's smart enough to say signal X comes up, I validated signal X, this is the known response to that, do X. And then my decision might be up that, hey, your response is X, hit the button for a guy to actually be able to do it. Much easier transition than for some guy to be like, hey boss, I just saw a signal, what does it really mean to me?
So EW is leveraging this now.
Right, so if you recall, at the end of 2017, the SEMA optimization, it was to produce a DOTMO PFP assessment brief to the vice. This whole model is what generated that complete assessment.
So to do that effort, who was the one to work this environment? Was that you?
It's me, Greg, and Keith.
Okay.
And the model comes pretty quickly. The model's not hard. Again, I'm not trying to undersell what I do. It is easy, but there's some science behind it. The model comes relatively quickly. The hard part is we traveled all around to get on people's calendars to say, here's what the model looks like, let's validate it. We went to our cyber, there was a Major Sanders up there. You know, did the dog and pony show. We did a whole 2-day conference, everybody's given their brief. He pulled me outside and said, I'm bored. Show me what you did. We sat down for 30 minutes and all the our cyber piece put into the model. And once he saw it, he's like, he wanted to use it more and more. But again, he's a cyber guy. One of the things he showed me, which is another interesting aspect of the model, if I can get the one open, is, so you see left here, attack by fire, block, breach. These are the object properties. This is what relates things. So if we're having a cyber capability, we'll put like, this is an attack by fire based on system X. All right, and what he gave us, and which I have infiltration highlighted, we have the maneuver definition in the model. We also have the cyber definition in the model. So as you're looking at this, you can see that based on what the maneuver would call an infiltration, this is what cyber calls it. If we see this coming up based on a relationship from one class to another based on infiltration, the inverse function is to do an interdiction. meaning our systems would have to do an interdiction to stop that, or vice versa. If we're the blue and we're doing the infiltration, our expectation is red's gonna do this. But we can build it into the model to show what the inverse relationship is. So if X is gonna happen, then you should expect Y to come back at you. Again, you can build smarter systems that way, you can build artificial intelligence that way. But it allows us to and there's more than this is just the ones me and him put together real quick to give a demo to his boss. But as we start to build this out, that's what your relationships are. So again, anybody who has an operational background can learn the model relatively quickly, but again, you'll be able to follow what the model tells you.
Right.
Where if I deliver a model to somebody out in the 82nd and ask them to validate it, they're gonna throw me out. They're gonna say, I don't even know what the hell these lines mean. In this model, we can actually build sentences out of it and say, X equals Y because, and that's something they'd easily be able to
So
validate.
you've sold me on the model. My thing is that if we would look as the requirements in integration division to leverage this for the things that we do, in order to maintain this and modify it as time goes on, we can't, I don't believe, not that it's not simple enough, but we would need an additional person or body to manage this for us as.
You will. So that's part of the reason why Matt is here. So if you go through IQs, or if you go through this experimentation, proof of concept, whatever the case may be, someone's gonna say, we need 3 MPU ground large. So where did you come up with the 3 vehicles? Where did you come up with the FDU or the personnel that it takes? This model will do it. I'm with you, but I'm gonna carry it on with you. So, Tickham EWs, man, with, I don't know, 13 some odd bodies that put this thing together, and so they give this mission to Tickham EW, which is a RID mission. So, what's the contract support that you have for RID?
Well, officially.
Right here.
Well, yeah, one.
You got one.
Yeah, but I mean,
But,
I'm.
So it's like a zero,
But that is only through another channel.
Correct.
So it isn't like the typical Tickums or other entities where we go up through the CDID and we're part of a overarching contract support. It's just, it would be no different than us going out to CIG6 and say, hey, we got a special mission. Because you're here for a special purpose. You're not here necessarily for the complete RID mission.
But if you did the complete RID mission, which is the integration piece, unless you have the GS personnel trained and ready to go to deliver that, it would require a requirements generation from you, from Colonel A, to be able to say, for us to conduct our mission through a manpower survey or whatever the case may be, here are all the tasks that are required of RID to accomplish its mission. Manpower survey. Do you meet it with your current personnel or do you not? And if you don't, then the development of getting you the assistance to accomplish that mission through this model can help you get it. So it comes back to a personnel manning. And that's why we're coming to you, because it's integration. This whole model, which you are sold on, is about integration. It's about the analysis aspect that you have. And now it is, how do you get the bodies that can help you do it?
And I know it's not a cost saving because it's really a cost plus, but if you look at if you actually want to do this without the model, the number of personnel you'd need versus having it contained in the model, it reduces that man structure exponentially. And
Well, so just remember, so there's this much here, and we only have today people that can do this much, and even if that's would go ahead and lighten the load so you could do that much, what they're gonna get consumed with is all these other pieces here. So while I am totally understandable of the fact that this could actually provide efficiencies that increase productivity about, threefold or whatever the nominal number is, there's a lot of things that are out there that would just move into that gap. Am I saying that correctly?
Yeah, I get
Yes.
what you mean. That's just the idea that it is one of the axioms I came up as a captain on storage space in the squadron. if you have a giant closet, you're gonna collect a lot of crap, right?
Right.
And so if you have a bigger workforce, you're probably gonna do more work. We all saw those like cartoons in the 80s where it's like, oh, computers are coming. Life will be so easy once
Right,
we have
right.
computers. All I did was allow us to
Yeah,
master
we don't need
and
paper
manage,
anymore
right.
because now we can store it on in an electron. So I get
So-
that. So I, in my mind, that we would, if we would go ahead and, leverage this, obviously you're not gonna do it, or am I wrong?
No, I don't think so. Well, of course I could. It was just something would go off the plate.
Right, so it would, we would need to look to say, okay, so whose mission and day-to-day responsibilities would it be to maintain this? So,
I've got a question on it. So, I mean, you've been around here a lot longer than me. So as I picked up this IQs thing, look at all the integration that has to happen for it. And right now, for example, I'm chewing on the O&O, the organizational and operations concept. About 40 pages. The first two versions I saw when I got here, they were written by committee, right? Because you have all these centers and units and people related to centers like our cyber and ACO and everybody that kind of flowed into that thing to write it. This version 8, point 8 that we just Chief Gill just sent me and I'm going through right now. It's the first one that looks readable just from a not writing by committee perspective.
right.
And I'm still looking at it and thinking about some of the structural issues that are just not satisfied with it when it gets to it. And I just wonder if back in 17, when we started down this happy little path, if we started with something like this that was organized and designed in a way, would it, would the output of all those shall statements, this shall do this, this shall do this, and these what these relationships are, start creating it. And then the other part of that I think about is, the unit, this battalion, company-sized battalion unit that we're putting out there, and then a second one in Germany starting in fiscal 20, isn't just standing up a 200-person unit. It's the first instantiation of Army's vision of 2028, the multi-domain operations. So Colonel Dawson is taking the team out next week to write IQ's education, that's what we're calling it, an IQ's education curriculum development working group. So if you made a super acronym out of that, it'd be really long even by itself. And so they're gonna try and tackle all these tasks. So each of the centers, schoolhouses rather, are gonna show up with their, well, here's how I would condense an Intel captain's course into 5 days. Here's how I would do a cyber captain's course into 5 days, and try and get this education level thing. But the real secret sauce of that unit and what MDO is going to do is the integration of those things.
Mm-hmm.
And I kind of expect, being a skeptic, that they'll get there and they'll have these 4 little Lego blocks. Space already does this, so the Space 101 course or 100 course is already there, so that one's built. I think we're going to get these things, and in the course of 2 days, that's probably all they can do. Like I said, the secret sauce, the interleaving of those capabilities, that's going to be MDO. And I think when you step back from what are we doing here, sometimes I get myself wrapped around the FDU and what is that, a 10 or 20 level task down in a unit, and I think our force designers are at that level in a way. It's getting this hybrid thing that sees the whole picture.
Right.
Like, CSA is smarter than any one of us, right? So he's seeing this whole thing of what MDO is. So designing that, imagine that thick black line there, if you go back to that slide, is the targeting process, the centerpiece of the mission, the multi-domain task force.
Mm-hmm.
Long-range precision fires is the centerpiece of that formation. And so all the stuff that we do, it's all about that, right? So everything has to feed into that capability.
Right.
And at a unit level, we're asking, NCOs, God bless brilliant NCOs, captains, God bless brilliant captains, warrants, God bless brilliant warrants, to do that. But, imagine yourself early in career and thinking not just about your little cone of excellence like a captain is supposed to do or a staff sergeant is supposed to do, but to understand a holistic part of that. To have chief of staff's all-seeing eye of the whole thing coming together.
Mm-hmm.
I just think something like this does that in ways that an intelligence expert, a cyber expert, a space expert, an EW expert, all SMEing together
No,
can't
and again,
do. So, I mean,
I
getting
am,
back,
I am a believer, but I also understand what GIGO is. So you know what the GIGO
Yeah,
is? Okay.
garbage in, garbage
Yeah.
out.
Garbage in, garbage out.
So the key thing is that if you're going to, you gotta take information and you gotta put it into the model.
Mhm.
Okay, so the question becomes, where am I getting the information from? So I've got concepts, I've got doctrine, I've got all these strategies and everything else that I wanna basically package together, and it's like a meat grinder, I'm shoving it into the system. So the question becomes, okay, let's just assume that, you know, everybody does the right thing to get the right references to
Yeah.
put it into the meat grinder. How does that information get parsed out? Meaning, can I take a PDF file or a Word document or even an Excel spreadsheet, throw it into the model, and that's going to parse the stuff out to then start going ahead and packaging, or at least having it there available? Or do I have to have somebody that's taking all this, or a part of it, and hand jamming it into this environment here? Because like you said, well, you know, we shall do whatever. So is that getting parsed out from something that's already been written, or is that getting hand jammed into the environment by somebody?
There's multiple ways to do that. So I highlighted this, export to CSV. So an ontological model is structured in the sense that if I have 1,000-line spreadsheet, that's probably not gonna be input. But if I have a spreadsheet that's been configured to basically just be how we actually see data, I can import it directly in. What we've shown is in multiple different formats, I can bring data into this. I can export data in multiple different ways into an Excel file. But the hand jamming is not that difficult. I've been able to, we did a space ops one, just a sole space ops one. We had that model done based on reading doctrine, and granted, we had some background in this area. We were able to have that model done in less than 24 hours. So basically 2.5 days.
Yeah, so maybe I'm misunderstanding model. So to me, the model means the skeleton.
So, no, the model, that's a good point. So when we say model in this context, the model is, so what you see here is representative of the model. It's all the relationships and how things come together. So for the space ops one, we were able to go through doctrine. I had space ops already through kernel luck in my base model. So we took all those tasks out and said, all right, now let's look at what doctrine says space ops wise. We were looking at the precision fires concept. We were saying, all right, you know, there's a massive role for the navigation piece of this. Navigation is primarily handled by the space ops, or the space officer. So we wanted to look at, all right, what is the relationship between the space officer and the targeting? So we took out, let's do the space ops. So it was all the relationships to the space ops and what his normal day-to-day job based on his tasks relating to what we call targeting and IPB. We had that done in a matter of days. We were able to do the fires process. Someone briefed my model at PEO Ammo. The fires guys out at Fort Sill said that's the best thing I've seen yet, so we feel it's fairly validated. Again, that model materialized, and it's all the detailed relationships. What you're talking about is garbage in, garbage out. There's a theory on that, on how we do modeling. With the new artificial intelligence, the unsupervised piece, you get garbage in, garbage out, but then you can do what's called regression to the system and say you're wrong, you're right, and then it fixes it. So you can actually have a very unstructured data through this process. And yeah, your first iteration might be 5% right, but it's better than the garbage you had. And then you tweak it a little bit and your next iteration's 10. What takes a long time in this is not the building of the model, it's to get the people in the room to validate that what we put in there is right. If we have better, like the garbage in, if we have the better data, your model's gonna be better, obviously, as you go through it.
Yeah, so I don't discount that. I guess I'm looking at, let's, just as one example, take what was the capability-based assessment, then capability needs analysis, because those are the processes that we have to work in to use this. This is where it helps, where that helps RID in doing those processes that then allows us to be faster in getting something out that drives a lot of things that that Keith's doing.
And I don't have appreciation for the scope of your workload, so I don't wanna undersell it, oversell it. So one thing we heard from General Morrison about a year and a half ago, 2 years ago, and I don't know the exact number, but it was 100 plus, 108, 109, whatever it was. He had that many OVs out of this tower. He's like, how do I manage if I have 100 plus OVs and they're not integrated?
Right.
We showed him the concept of the ontology. He's like, you guys need to come back and see me. Unfortunately, that schedule never worked out.
But the problem, the reason you get to 100 OVs, or 109, or whatever the number is because
Stovepipe.
you have not done the work back here.
Exactly.
That's where we start.
And that's what we're trying to do, is say, let's get to the point where we never have the 100 OVs.
Right.
Let's show the integration. If we can, and the PMs, I used to work a lot with the PMs, they would love to have this information coming in, because what happens, you guys write requirements that are valid requirements. Then you have some engineer who's been sitting in the lab for the last 2 years, has no idea what you're really asking for, say, oh, I know what that is, that's technology X, I'll just do it this way. And it's all in geek speak, but the operator can't use it because it doesn't help any of his tasks. If it doesn't make my job easier, I'm not gonna learn how to do it. And that's where we can start to bridge that gap, because we can get very technical in what the system design looks like based on the requirement validation. How they touch each other is the key. It's that integration. This ITN piece, they're trying to bring us on board right now contractually, because they know it's gonna fail if they don't look at the integration, because it's a mix of cost products. There's not a company out there that's saying, hey, I'm concerned with how the Army does JVMF messaging, so I'm gonna build my waveform, just do JVMF or SMTF. So they're not gonna work together, and the Army knows that, or PEO knows that. But they can't integrate right now because they don't know what it looks like. If we can start to show them what that looks like, then we did a study a couple of years back. I think it was actually part of the ITN piece. We actually did an estimate that if we had this model completely done in 19E, got funded, without the model, it was gonna be $1 billion plus to do it. Based on how we actually could integrate and organize the schedule for people, that number came down about half, and that was probably a low estimate. We could probably get it down lower, because you can be more efficient in the PMs. You know exactly what to build, you know what exactly the cost. G8 would love to see something like that.
Right.
But your worries are all valid.
Yeah, I'm way back here.
Yeah.
I got it. When you get to getting a solution, aligning funding to that solution, and obviously all the rest of the .mil PF, it is, where we start is we're taking all these references and we're putting it into a process that says, out of all these references, based on this certain area of operations, what are my required capabilities? So I could see where, wow, I mean, this would help validate, because I've been through that process several times, and we come up with 248 required capabilities for cyberspace operations, and that was not accepted by Big Army, because it's like, okay, that's too many required capabilities. My argument was that, well, if we did land operations or unified land operations, I guarantee you're gonna have more than 248 requirements. But at least we could come back and say, well, hey, we put it through this model, it has done everything to look at duplicity and where the dependencies are, and this is what we got. Where the struggle is, and where that all came in is, okay, how do you, again, pull those pieces out? And a lot of it is mental exercise in doing all that, because you don't have enough time to go line through doctrine or all this other stuff and do that. That's where the time takes it.
Hey, Russ, on that, I've had a very similar line of thinking on this. And one of the conclusions I came with that concern is just the serial process of going through each of those things. What happens, my challenge, and I think the human brain challenge, is you go through that in a serial way, and that network never gets built, because you can only manage so much of it in your head. The sharp person can read a whole chunk of stuff and be able to pull selectively, because human brains can be better than this all day long.
Right.
Except for the volume question.
Right.
Right? On a little chunk of that model, human brain way faster, way better. On the volume part, can't handle it. And so organizationally, this is like a bureaucratic thing. We parse up our little bureaucracy into little stovepipes of excellence.
Mm-hmm.
And then by the intelligent design of our bureaucracy, we hope that all the stuff flows together into a thing. And I just see this thing being able to connect all of the, you know, our main wheelhouse with doctrine, organization, material, personnel, getting those stitched together in a coherent way. I can tell you, I feel that trying to get this
But
IQs.
what I would, where, to me, the power would be is, and where you gain a lot of time, is I just upload references. And the artificial intelligence is a thing that goes through, just read through them all, it starts to parse things, it starts to do relationships,
You
and
take
then.
a FM, you do Control F will, Control F shall, Control F must, will, shall, must. You go through the entire FM. That's the.
So when you say
so
go
that's
through the
that's basically
entire,
what we do.
you
is
go
that
through
how
the
you-
entire,
Okay.
but when you say go through the entire FM, that's not a person going through the entire FM, it's
I hear what you're
this,
saying.
this tool.
Right, I
So,
don't
so
know.
here's
This
the other
thing
thing,
also
you're
has-
actually right.
And I hate to be a dead horse, but I
No,
mean,
yeah,
it-
no, we, actually, you're hitting, we actually went to Amazon and a couple of other larger companies a few months back, and to do exactly that, is to build the knowledge base out of FMs. The problem is, when we went to Amazon, they're like, yeah, we own all this, and, no, we can't let them own, obviously, the structured data out of the FMs, so it never really went anywhere. We're doing the same thought process. We've come up with efficient ways of actually doing that. What you'll see, though, is we actually have a library of over 200 plus ontologies already developed that has probably the majority of that stuff in it. Now, importing ontologies to another ontology, it takes one push of a button, and I will have all that structure in there. But there is a delta, and we'd have to determine what that delta is to determine. But this would by no means be a start from scratch. We have a blank piece of paper now, read first line, add something. We'd probably have a good 20–30% based on what you're looking at already built, which would give us a structure to then say, all right, where is our focus area? Let's go do those up front, bring those in, and build it out. And then you reduce that workload on a person. I've actually gone through, and as Mike was saying, I can't remember the number of doctrine. I went back. It's funny, I've read more doctrine out of the Army than I did in the Army, which shows you what a quality officer I was. But extracting the data out, I probably went through 6 or 7 FMs within the matter of a day by doing very similar ways doing it. There's a lot of fluff in there that once you read one, you can kind of, got it. We already have.
but is it you determining that, or this determining?
It's me, because I understand the operations, but, so, another war story. So, my partner, he has a 19-year-old son, very smart kid, 3rd or 4th in his class, but decided to take a year off before we went to college. We built the structure for how we did this. We wanted to test it to see, all right, is this simple enough that we can get somebody to do it? So he volunteered his son. We sat him down, I forget which FM we gave him, but we said, hey, build a model out of these first 25 pages of what, and we defined what the classes were. You saw that base structure, organization, so forth. He was able to build it, and guy with 0 operational background, never touched the Army, can barely spell Army. Sharp kid though, 19 years old, was about 65% accurate. So the training level to do this is not difficult. You're right, it's the manpower, it's the hours. Like I said, we have so many models that I bet you we'd be able to start, especially on the SEMA side. We broke that down to a NatSAS on all the processes that were done, the tests are being done. A lot of those 200 plus capabilities you mentioned, we probably have a lot of those in the model. Maybe the names aren't the same, but changing a name takes a second.
How long did it take your partner's son to do those 25 pages?
He did it within 2 nights, and then he worked a full-time job, went home at night, probably playing on the Xbox for a couple hours, read a little bit and did it. So within 2 days, he sent me the model. I looked at it, I'm like, yeah, at least the first couple or
So
something.
certainly not quoting anything, but if he had 6 hours, 3 hours a night, or 4 hours, and shoot through 25 pages, and see, that's to me the magic of this thing. Then you lock it into a system that keeps interrelating chapter 2, chapter 3, and chapter 4.
So what's the backside?
So the backside of this is, if you're familiar with RDF or OWL, those are the 2 languages. So RDF is Resource Description Framework, which is your semantic web language. Anything AI, anything semantic web, Google, every major player out there in the industry where you see anything artificial intelligence uses RDF or OWL. OWL is just the ontological web language, which is a unique language for building.
Just right on on a laptop?
Yeah, so the Protege is a downloadable application from Sanford. There's a whole community on Protege that adds plugins and wikis. We're on version 5.5 now. So but it's, Protege is just a tool set that allows you to build the ontology. It's a language you save in. I can export in JavaScript, XML, Excel. I can create some Word document stuff. That's kind of chunky still. I can go to other modeling languages. So if you have a developer that says, hey, I'm SysML only, which a lot of them are, because that's what DODAP is, I can export this model into a SysML view. So the structure behind it, so you're probably also asking a database.
Want more?
Hey, Russ, maybe this is what you're asking. So on his laptop, he's got this model, it's got 1,600 objects, you know, the boxes,
Mhm.
you know, and then the related, you know, connections.
Yeah, this one,
The
this
links
is the
and the-
ITD one, this
the
is
links and the
2487, so it's quite a bit bigger.
Oh, okay, so that's, you can run that on the laptop, so we're not
I
talking
have
like
5 up and running
a
right now.
mainframe that
Yeah.
you gotta,
I have 5 models open right now, all running on my processor.
What if I had 3 people existing in different locations that went in here? Is there?
Perfect. So, we've done this. So this is where we kind of cracked the nut. We realized
yeah.
we had to get a structure. That's why you see that. So as long as everybody follows that structure, I can work on a portion of the model, you can work on a portion of the model, Mike can work on a portion of the model. We can check it in at night, and the system automatically integrates. And the beauty of that, the piece I didn't touch on, the model actually does what's called inferred or inherited relationships. So my example is always, if I know Mike from work and I know Keith from church, if I don't,
Go to church.
yeah, well, the other way around. If I just say I know Mike and I know Keith, the model's going to say, well, Keith should know Mike. But if I say no, I know Keith from church, I know Mike from work, the model's going to say clearly you don't know each other, unless I put a relationship of where Mike goes to that church every once in a while. Then it will say, well, if you know Keith, you probably introduced Mike to Keith at church at some point, and the model's smart enough to say these two should know each other. Do you validate that? So as we start to build these 248, the first, let's say 10, we're going to build some significant relationships in that. When we get to 11, 12, 13, the model's going to start saying, well, you related this to this and this to this, this should relate to that too. And the model's doing that at 1,000 times a second, and all you're doing is, yep. So I don't have any of these turned on right now.
Is it like in LinkedIn when it says you might know? this?
Exactly.
Yeah.
So LinkedIn, Amazon, you know, I use this, you know, you're shopping for a drill. You type into Amazon, you know, certain drills. You don't buy anything. You go to another website, what do you see? 1,000 drills in the ads. That's an ontology. That's an ontology that's behind the scenes that does what's called natural language processing, and it's not the way we think about it, but there's a voice way and also a word way. That's gonna say, all right, this guy's looking at and it's Google based and Amazon based, and it's gonna push a bunch of drills to you. To import ontology, so here's what I showed. So the inferred, it actually builds a completely separate model behind the scenes. It says, here's all your inferred relationships. There's a button I push to say, I forget the term, accept all or introduce all, something like that, and it will bring all the inferred relationships in. Or I can do it one by one, or I can do, you know, groupings of them. I can click on this parent list and say, all the ones for NetOps, I validate, move those in. So it's a simple, quick fix, so you can have disparate people to do this work.
So if we're thinking, like I'm thinking about the IGs all the time. So if ICA's chunking on their part, they can cleave off a section of it and send it to us.
Mhm.
They could also cleave off a section and send it to Tickham Aerial because they're working the ISR task force. And so the same, you know, if a Gray Eagle UAS does these tasks, it'll do it for an IQ's battalion, it'll do it for a MI battalion, it'll do it for whoever uses it. So the chunks, the branches on that thing can be cleaved off and sent wherever and Lego blocked back together. In a
Or
way
it could
that-
be like from your earlier example with how EW and MI are both in that same board together. You could have EW and MI separately input their chunks, and then then send those to the other, you know, exchange those, and the other people say, yes, this inferred connection is correct. That I do actually attend this board and do this
When we
function.
go to exercises to validate the concept, so the .mil PF assessment that our horses are doing, I think they would look at something like this as the secret sauce maker of IQs or SEMA or the EW experimentation and demonstration, because it combines these previously uninterrelated things into a interrelated thing. And so, for example, I mean, a simple example is the EW sensing and the SIGINT, the ELINT collection. You know, so there's Title 10 and Title 50 authorities that do that. But hey, big secret, wave passes through the air,
Mhm.
an antenna, you know, vibrates, and a processor in the computer interprets that to be a certain signal, right? Exact same thing. So I presume that there are going to be processes that are going to happen in the back of a twos van someday where we can demonstrate that. Now the legal authorities, that's another issue that can get done, but you take this point of execution up until you have to diverge. Okay, this is now SCI because you added this type of information. This is operational information, so it's only secret and can be used by every operator. This is going to capture not just that signal flow, but the tasks that the soldiers do, the soldiers themselves, the equipment that it uses, that whole .mlpf, that layer. So one of the things I had no idea it was called OWL in the intelligence community. They use a thing called the Analyst Notebook.
Mhm.
And so for human hunting, like we've been doing lots of in the last 2 decades, you get this human, he's got lots of attributes, who he's related to, who he gets money from, who he talks to, where he drives, where he sleeps, all these things that, you work out. So you build all these attributes for that person, and to me, call that .mlpf, right? His personal .mlpf. And then you do that for the other people that you're kind of generally interested in. You think this guy's a target. And when you step back from it, you pull the communication string on it, and you find out that everybody in that region communicates with this guy. No idea who he is.
Right.
No idea where he is, but all of a sudden you found something that's super important. And I think, so that's hunting a person, right? But the idea of all that data is just sitting there, just like all this information is sitting in FMs, and it's sitting in the heads of NCOs, and it's sitting in these stovepipes of excellence that exist right now, and we're trying to make this, again, the secret sauce of MDO. I think this helps us see the network, see the matrix, right?
So I guess my question is that, are you receptive to doing some sort of pilot inside the RID on a small scale? Because where I'd like to try this is with the capability integration mapping, where we're taking multiple requirements documents and showing where the hooks need to be and where the redundancies are.
Yeah, I think, that or any myriad of issues.
Well, again, I'm trying to think small scale.
Yeah,
I mean,
I
when you
think
start.
that's-
I tell you what, that
Good.
could be an easy and small. I know
I'm
I
gonna
don't-
do
I don't
it
wanna-
easy and small.
I don't want to get ahead of you. I've seen this. I had no language for owl, NRL, daikui, those verbs. And
Well, daikui I made up, well, actually my partner made up. So one thing I want to point out that the colonel mentioned, so these are high level classes, these are the parent classes. So under people, you'd have the Intel guy, you'd have the EWO. So they work on that section, they build their own relationships, and then simple push of a button, we inject it back in, and now we have the EW and the Intel class underneath here, all the interrelationships, and then we'll sit there and say exactly what he mentioned. Intel's related to these 5 things, EWO's also related to these 5 things. Should they be matched somehow? Yes, no, maybe, and then we can build a model straighter out of that. But that's exactly what the ontology is for, is to, I was down in Huntsville, and I was listening to a radio station. They were talking about one of the medical centers out there just did a massive ontological piece. And theirs was 2 gigabytes of data. I've yet to get my models. My models are fairly large, to a meg yet. So you can imagine how much data can actually be put into these things. So the model that had 2400, I think is 700K. And that's one of my larger models. I have some of the other ones as I start to integrate more of the space off. So the lower level ones we did into the SEMA optimization, that one will probably get to about 4,000 linkages. But it's still probably be about a meg saved in an OWL format. But that's exactly what it's for, to parse out, to pull out data from the ontology. I can split a whole ontology out, say you guys go work on this, and then bring it back to me and bring it back in. It's a simple push of a button. And our experiments with this, the older versions of Protege didn't work very well. 5, they've gotten it right. I've had nothing break on my last 5 or 6 imports with new 5.5. But taking a small piece and showing the value in that, I think would be something we'd be able to achieve. As long as you guys have a good description of that, we can probably turn around the model fairly quickly, and then come back out here, sit down with you guys and see, probably pick your brain a little bit more about how the relationships work. I think I might have mentioned this, but I didn't touch on it too much. There's another acronym called Sparkle. Sparkle is where the real power comes out of this, but unfortunately doesn't have a clean interface. Sparkle is how I query it. So if I want to ask it a question, so back to the kernels example, if I want to know Intel tasks that are performed on Prophet that do collection, I'll just ask those simple things in the model, will pull everything out, and then I can add the next piece. I can add EW does the same, basically same data. It'll show me where the linkages is, and I can build a very static report that says, here's what the Intel guy's doing, here's the data the EVO needs, he's not getting access to it because he doesn't have access to this piece of equipment. And that's something, again, it's analytics that we can go back to somebody and say, we need to change something in here because we're missing the boat. We're either going to spend $100 million more to build a new system, or we're going to find a way to get the guy the data that's coming out of this to him.
Right.
Does that let you compare two things as well? So let's say we have an O&O and the first draft of some sort of document. Can you pull both those in the system and say, okay, based off the O&O, what is this person responsible for?
Yeah.
Based off this new version, how does that change? So you can see and say, okay, based on these changes, this
Or is
and
it
this have
covered?
changed.
That's the thing.
Yeah,
A lot of
what
times what
gaps
happens,
now
you
are
write
there.
something and then the document comes out and you missed a huge piece that,
So the work we did on seam optimization was exactly that. What are the seams, what are the overlaps, what are the gaps? We're both doing something here, why are we both doing it? And then we can build in the model that it's needed for both. So a good example is update running estimate. Everybody had that task. The system is going to say, well, why do you have everybody doing the same thing? Well, they're not. There's an EW running estimate, there's a fire. So we can then delineate that, no, there's separate running estimates, but everybody has that same task as a part of their AUDL. Or we can say, no, that running estimate should be combined, I know it's not, but for EVO and cyber should be one running estimate, so we have a duplicative task, but let's say it's a needed task, let's delineate what role each of them play in it by what data they provide to it, and that's again, the DICUI. You mentioned the knowledge. There's not another model out there that will capture what's in the guy's brain. And we don't get that necessarily out of doctrine. We don't get that based on, it's more of, all right, doctrine tells me he should know this, schoolhouse trained him in this, his experience knows what the knowledge is. That's what we can start to extract out of the SMEs and start to put that in the model. So an expectation that there's a certain learning curve that has to happen at this point.
okay. So I think what I'll do, when Carl comes back, I'll discuss what we went over. Once I get his guidance and thoughts, we can get back with you and then go from there.
Okay.
That's
Yeah, it's too easy.
a good roadmap.
Too easy. I know Lori mentioned that she, if there's any receptivity, to talk about getting scheduling. So the short answer, could you do a small? Yeah.
Right, I mean, the thing is that I truly understand the power of this.
That's awesome.
But of course, it's like anything else. I understand the power of Hellcat, Dodge, but I may not be able to drive a manual, so or I can't pay the insurance, or man, it sucks up a lot of gas, that I don't wanna do. And so there's always those pieces there that you have to identify. And so I think, again, if we can start small and say, oh, wow, I mean, this really helps, and what can we do just even to support that would be potentially a quick win. And then, oh, by the way, what other things can we do with it as we would expand it out to do the old capability-based assess process, or as we get into writing either ICDs, O&Os, FDUs, it'd be great to take all that stuff, getting spit out from a functional solution analysis, and say, here's the initial going in structure of what we think you need for this mission. And then you can start getting the MOSs and all this other stuff. But, I mean, even from when we transitioned from signal COE to cyber COE, it would've been great to have something just to throw, like you said, get a bunch of information in there and help taking the Army Common CDID design, but
Oh, yeah.
providing that piece of, okay, what should the red really look like, you know?
I started thinking about this, you know, how the Army works
Mhm.
thing.
Right.
One of my maxims I came up as a major was, nobody understands how the whole thing works. It's that simple. So we all do this SME level work in our
Mhm.
stage in the puzzle, but you think about, you know, developing a new unit, like a new concept and unit, and it's really kind of like this 7-year evolution where you start way out at, you know, concept development, and then you get into requirements definition, you know, at, you know, 5 to 7, 3 to 5, and then at 1 to 3, you're prototyping, experimenting and stuff. And so at least the 3 experiments that we've been handed to go execute, or pilots we've been handed, it's like, do that in like 18 months.
Right.
And so this high risk of desynchronization is there. And then the other part is, I can't tell you, every day I turn over a rock and say, oh, there's another part of this system that needs to be talking to each other.
Right.
And you could do this on the Army, you know, and
Yeah.
because there's disconnects, and so you get that process part. I think about, you know, everything that I've learned about how this IQ's unit is supposed to go together. I think the exact same thing as far as who does the equipping, who does the training, who does the organization, who does the support agreements, who does this and this and this. That happens through experience, you know, the wisdom that happens in between an NCO's ears. All that knowledge, the process part, chunk could be in the SEMA section, chunk could be in the EW experimentation demonstration.
And you can start to incorporate that into training, you can start to incorporate that other places,
Yeah.
so it becomes more than just knowledge, it's
I mean,
shared
this
knowledge.
is something, while, yeah, it could potentially provide a lot of value inside the CCOE to truly take something, the potential of all that, you would have to bring it up to the DA level.
Yeah,
Because
that's right.
it'd be great to say, well, you know what, yeah, you know, here's an example. So, DCO tools, where we got some that are very specific to the CPTs and maybe the RCCs, and then you've got some that are common across the board, you know, across all the defensive forces, of course, HBSS and ArcSight and all these other things. Well, who should pay this bill, or what requirement should pay this bill versus what requirement should pay that bill on a percentage standpoint? So when you look at a portfolio and say, okay, we can take chunk of this, chunk of that, chunk of that, boom.
Can you pull up I don't know if it was a slide or part of the model where you had I think it was EW sensing and everything that went into that, and then the people on the other side of it?
So, was it one of these, or?
Let's just use that one. Yeah, I think it was actually. So I got the whole of the Army.
Every time I go screen.
It's all right, good looking doggies. I got the whole of the Army thing. They're like, this would be awesome if the whole Army ran this way, everything would be connected, and we could all see the matrix together. Chance of that happening? Well, you know, 2028 is not soon enough, right? But let's say that's the cyber center, and all that knowledge about who should pay for what and who should do what things. I think just inside our center, if we just maintain this locus of control, that's the us part of it, and then you move into another portfolio and another portfolio, all this goes with it. Whereas if this is the DA staff, they've got their own perspective, because you could just as easily, instead of making this your primary thing, what am I looking at in this model, you can look at that. I mean,
Yeah, the only difference when you start looking at PNR forms and things like that, that start aligning dollars to requirements and capabilities, you know, those are all managed by the PMs. And so while we can kind of get our hands on them, you know, it's that, everything you just said there, and then that would have to be linkages to that would then spit out everything you would, you know, potentially see on the left-hand side. But, you know, there are specific entities that have deeper levels of information that the CCOE won't be able to maintain, but yet impact allocations across the board, whether it be people or dollars. so.
Right.
Yeah, it's an exponential.
Cause I mean, you know, again, let's pull the thread. You could sit there and say, okay, do I need a separate PM, or can I do this? How many more people would I need over here to do this mission, to do all that? So, I mean, you know, again, I could sit here all day and write on all these boards on all the potential that could do it. Of course, again, we only can influence what we're doing here in the red, and then if it is something
Right.
that like, wow, this is great, and Ticket EW comes in and says this is great, maybe it gets, you know, subsumed by the entirety of the CCOE, and then somebody comes here, Futures Command guy.
Futures
wow,
Command needs something
this
like
is
that.
awesome,
Hey,
so now you got Futures Command, you know, pulling up, so it would have to go that route, I mean, you know, bottom line, but that's why I said, let's
Gotta start small.
start small, and
Yeah.
we can go from there, but like I said, let me get the Colonel's thoughts, and we'll talk about it, and then,
Yeah, we have a lot of believers in this. Dr. Conley up at OSD, Mr. Nucci at headquarters DA, all those guys are like, this is great. You know, we need, and they're really trying to push us down to this level to say, this is where you can really have the most effect. So, yeah, talk to Lori. I'm subcontract Lori, but Lori can get to me any way she needs to.
yeah, I know Lori about that, so.
Yeah, yeah, great. So she's helped me out quite a bit. She sees the vision for
So
this.
do you know Mac Martin?
Who?
Mac Martin? Is that
Mac?
name sound
No,
familiar?
that doesn't sound
Okay.
familiar.
I didn't know if he at one point was interconnected, I don't think he was working for Lori, but, they were doing something, so I was just curious on what he was doing. Nowadays,